Today for calculus review, we're on 2.1. We're going to take a look at inverse functions. And so we're going to find the inverse of a function. Now in pre-calculus, this was a much more involved lesson, and with inverses, we also talk about this concept called one-to-one. And one-to-one basically says if f of a equals f of b, then a equals b. If you can prove that statement, then you can say that the function is one-to-one. Now visually, another way for you to prove if a function is one-to-one or not is you got to look at the picture, right? If your graph does something like this, it's going to pass something called the horizontal line test. And if it passes that horizontal line test, it's going to be a one-to-one function. But if it fails the horizontal line test, in this case it fails because it passes through more than one point, then it is not a one-to-one function, and so we would not be able to use function inverse notation. So the process in which we find the inverse, by definition, the inverse is swapping the x and y's. Okay? Even though inverses, it kind of undoes our function, essentially what we're doing is we're swapping the x and y's. So let's do that. If I have y equals 1 minus 2x over 5, well, if I want to apply the inverse or make this into my inverse equation, I swap the x and y's. So there we go. Now this represents my inverse equation. But I want to be able to write this in terms of a function. So I need to get y by itself. And so the rest is all algebra in trying to get y by itself. And so I'm going to multiply both sides by 5. And so I'm going to get 5x equals 1 minus 2y, because those will cancel out. And then I can subtract 1 on both sides, and so I get 5x minus 1 equals negative 2y. Then divide both sides by negative 2, and so I'm going to get y equals 5x minus 1 all over negative 2. Now this function, it was a one-to-one function because I stated that it was a one-to-one function. If your function is one-to-one, then we're allowed to use the inverse notation, so I can say f inverse of x equals 5x minus 1 over negative 2. Now, there's probably different ways that you can write it. You could put the negative on top. You could also say it's like negative 5x plus 1 over 2. Either or works. Doesn't matter. That is going to be my inverse function. So the first thing that I did is I replaced my f of x with y so I can manipulate it. And so then I interchanged the x and y, because when it comes to the inverse, the domain and range, they swap. So that's why I'm saying my x and y swap. We switched places with them. And so after I wrote for the y, I switched my x's and y's. And then from there, you just solve for y. And so I got y by itself. Now because it's a one-to-one function, I can use my inverse notation, and so I just replaced y with my inverse notation. Example number 2. So finding the inverse of this one-to-one function, so that first step, y equals f of x, I want to replace my f of x with y. Then step 2, interchange my x and y, so I'm going to get x equals 2y over 1 minus y. Then from there, I need to solve for y. I need to get y by itself. Well, I have a y in the denominator here, so I'm going to multiply both sides by 1 minus y. So they do cancel out there. And so I get 1 minus y times x equals 2y. Yikes. Well, I have x's and y's on both sides. And so if I distribute this, I'm going to get x minus xy equals 2y. Well, the issue here is the fact that 2y and xy, they're different terms. I can't just add them together and combine them together. So if I'm not able to combine them together, I now need to group them together. So I still want to bring this xy to the other side. So now, when I'm saying grouping them, what's in common? A y. So I factor out that y. And so now I can get y by itself by dividing both sides by 2 plus x. And so y equals x over 2 plus x. And so now I can replace it with that function notation. And that's going to be my inverse. Now on this last one, I wanted to point this out. This function is not one-to-one. Okay, this creates a parabolic looking function, which is going to fail the inverse function test. So it is not one-to-one. Now having said that, because it's not one-to-one, you can still find the inverse. There is still an inverse equation. There's just not an inverse function. So I still replace my y's, and so now I swap the x and y, so I get x equals y squared. And so now solving for y, if I take the square root of both sides, I get y equals plus or minus the square root of x. And so technically, this right here, this represents my inverse equation, not inverse function. Because remember, because I have that plus or minus, it is no longer a function. Now if I wanted to try and create something that would represent it as a function, I have to isolate the domain. Because now this image is something like this. There's the positive square root of x, there's the negative square root of x. And so I have to limit my domain so that I can say that it's going to be a function. And so in this instance here, I could say that f inverse of x equals either the positive square root of x or the negative square root of x. But we would want to limit the domain for us to be able to say that it's going to be a function. But this right here is my inverse equation. So in closing, what did we review today? Well, we talked about inverse functions and one-to-one functions and how to find them. And I used the phrase one-to-one. What does that mean again? What does an inverse mean or imply? And what happens if I take the composition of a function and its inverse? So you may have to go back and take a look at some of my older videos to kind of figure that one out. But I would love to hear from your comments. Now this does conclude the lesson. If you have any other questions, please do leave them in the comments.